Okay, all right. Well, I've uploaded I've pushed a new notebook, a draft of 0202 onto our repository, and we'll see how far we get through it. If we get through everything, we would have covered lists, tuples, booleans, bools, and dictionaries. And so we'll see. We might not get through everything. That's okay. I'll just copy the stuff I didn't get to into Friday's notebook, so no problem. Okay. So I've Jupyter Notebook running, although it's not working. Okay, here we go. All right, so last class on Monday we covered copy, append, insert, and extend. And all of these were mutable methods, okay? So you run any of these things and it actually modifies the list itself. There's no need to do this operation and then save it, okay? So if you wanted to, it modifies the list in place, like extend, you can it modifies the list in place. Whereas if you take the list and you do the plus sign with another list, then it produces a new object, which, is going to be your extended list. But that's a new object, and if you want to store that, you've got to assign it somewhere using the equal sign, right? So those are some things, okay? Here's a few more methods that modify the list in place. So you've got the name of the list, dot remove, dot pop, and dot clear, okay? So for example, in this first cell here, I've got Liz, I've got the family list again, okay? We got Liz, 1.73, Emma, so on and so forth. And I'm going to just do fam.remove, and then you just give it, the thing that you want to remove. So in this case, I'm going to say remove Emma, and then that will modify the list itself. And so when I print fam, it will print the result of the operation, and it will basically be a list where it's going to show Liz, 1.73, and then 1.68. Emma has been removed from the list, okay? And so there we go. Right. And again, even if I didn't print this out, the operation takes place, the list is modified, it won't display. Okay. If you've got if your list has multiple of the same object, so here I've got the string A appear twice in the list. When you do a remove operation, it's just going to remove only the first element that matches. So reading left to right, it's going to remove, or I guess going in the order of indices, it's going to remove the object with the lowest index that still matches the thing that you're looking for. So here, we're going to just remove A, and then the result will then be a list. S will be 0, 2, A, and 4. Okay. If you say remove something, okay, so here I'm saying remove string B, but B doesn't even exist inside the list, right? So if you tell it to remove something that doesn't exist in the list, it's going to throw back an error. It's going to say, I'm not able to do that, right? It tells you there's an error in list.remove x. X is not in the list, okay? It gives you back what's called a value error, that the value you provided the function is producing some kind of error there. Okay, so that's remove. Remove is pretty straightforward. You just need to know the thing that's in there. Okay. Here, let's see. So let me just kind of print out S here. What if you want to remove something at index 3? What can you do? So index 3 is this number 4. Like, what if you wanted to remove that thing, but you didn't quite know you didn't quite know that it was the number 4? Can we do that? So if I just type in like 3, what will this return? This is going to return an error, right? oops. Okay, it's going to say 3 is not in there. But if we want to remove the object at location 3, what can I do? I can use brackets to kind of say, give me the item that's at 3, and then we'll remove that. Okay, and then now if I ask for what S is, what's going on? Okay, it has indeed removed the object at index 3. So you can combine the remove method along with kind of brackets to remove objects at a certain index, okay? You can't just give the index because it's going to look for that value. So this will be okay. All right, here we've got the function pop, okay? I don't know if you guys are familiar with pop, but basically what it's going to do is it pops a value. So fam.pop will take the, by default, it's going to pop the last item in the list. So in this case, it's going to be 1.89. Okay, and notice that I have j equal to fam.pop. Okay, so what fam.pop does is it modifies list fam. Okay, it's going to modify the list in place, and whatever object it popped or removed, it's going to return that, and you can store that value somewhere. Okay, so here fam.pop will modify fam. Okay, so fam will no longer include the value 1.89, but 1.89 is going to get stored into j. Okay, so you can modify that somewhere or use that value somewhere, and then when you ask for fam has been modified as well. Okay, and so you just have to kind of be okay with reading code like this, understanding that this operation has modified fam directly. Okay, and that's something you kind of have to get used to. Whereas in R, that was never the case, right? You did an operation to an object. If you wanted to kind of save that change, you had to then reassign that value somewhere. Okay. If you you can specify a value like 0. Okay, and here it's going to pop the object at index 0. Okay, and so if you do fam.pop 0, in this case, it's going to pop the value Liz. J is going to take on the value Liz, and fam will be the list without Liz in there. Okay. I don't know if you guys are familiar with the idea of stacks. Stacks, the standard pop behavior is like a stack of paper where you keep adding stacks and then you just pull off the top sheet, right? And then so that's going to be kind of the last thing that was thrown in is the first thing that comes off, right? And the other is the queue, where it's like, I don't know, whatever you call it, right? Things line up, and then so the first thing that went in will be the first thing that comes out. That's going to be pop 0. Okay, and then fam.clear just clears out the entire list. All right, so this is if you do that, then fam will just end up getting everything removed out of there. Okay. All right, there's a few other things that you can do. So these things will not modify the list, but they will return values, okay? So you can do list.index, so you can find out what is the index value that contains this object here. So you can say, like, what is Emma, right? Emma, or what's the index for Emma? And that will return 2, okay? So here it tells you that the index of something that matches Emma will be 2, okay? If you give it something that doesn't exist, so if you say fam.index 5, okay, 5 doesn't exist anywhere in the index, it's going to throw back a value error. Okay, over here, if you give it, here you can do a count, okay? So here it says letters.count A, and it's going to tell us that it has found the letter A 3 times in our list. Okay. If you give it a list of lists, it only kind of counts at kind of the top level, And so if I say count how many times you see Emma, it's going to say it doesn't exist anywhere in that list, right? Because Emma by itself doesn't exist in this list of lists. So here we've got 4 lists inside fam2. So you can say, you know, how many times does this particular list exist? And there we go. Okay, so count is going to be 0, and this list exists 1 time in our list of lists. Okay, so these are all just kind of operations that we can do with lists. Here are some things that we can also use. We can use sort, and we can use reverse. And these, again, will modify the lists in place. Okay, so here we can ask to sort the list in place. And so here we've got fam. I can reverse it. Okay, so here we've got Liz, and then the last value is 1.89, and I can say reverse this list. And it doesn't, okay? So the operation took place right here. It doesn't look like anything has happened, or we can't see that anything has happened. But indeed, if you ask to print out the contents of a list, it has been reversed, okay? Whereas, and if you say sort it, it's going to try to sort this, except it's going to complain and say, I don't know how to sort when I've got numbers and strings together, okay? So it's going to say, I've got a type error, okay? Comparison, be kind of this less than sign, that's how it sorts values, is not supported when you've got strings and floats. So it's not going to try to, it doesn't do any kind of upcasting where it converts values into strings and stuff, okay? But, so here I've got some digits here, okay? I've got a mix of integers and 1 float value, all right? And so if I do this, sum digits, and then I do sum digits dot sort, again, the list is sorted in place, right? There's no need to say sort it and then save it, right? So, you know, in R, if you had a vector and you said sort x the vector, you had to then assign that, you know, whatever it was somewhere to get this saved, to save the sorted results. But here it just sorts it in place. All right, and then and if you check, indeed it prints out the values and it preserves the data types. Okay, so we can see that these are still integers or ints, and this is still a float. Okay, it doesn't try to convert everything into floats or anything like that. So lists allow for a kind of the mixed data types, and it's still able to sort numerically. Understand that 5.1 is indeed less than 7. So, so there you go. Okay. So you know, if we ask what is this type, indeed it still says it's a float. Okay. You can sort in reverse order. Okay, it's no problem. All right. There's another function, okay, called sorted, okay, and this behaves a little bit more like the sort function that we've seen in R, okay. So notice that these things, this function sort is a method. You write the name of the list dot sort, okay, so you give the name of the list and tell it dot sort, and it's going to sort the list in place. Here, okay, I'm redefining some digits to be out of order, and then here sorted will return a sorted copy of the list. So the original list remains unchanged, and it's going to return an object where it's the values of the list sorted. Okay, but if we check back to the original list, we can see it's in its original order. Okay, so this is kind of how R behaves when you have a vector, right? You've got a vector x, and you can say sort x, and it returns a new object. But if you didn't save that somewhere, the x remains unmodified. Okay, and so that's the difference between the list.sort, the method sort, versus sorted, the standalone function. Yeah.
Is that also the case with the list.sort reversible true and then?
Yes.
Okay.
Yeah. So with reverse.true, like, so we can go, we can just type in Python the sorted function. Okay. Do we have the original sorting how to? Let's see. So we've got sorted. Where's the? So you can do it for dictionaries and stuff. It's too much. Okay, but you can give it basic kind of the arguments where you want reverse is true or something like that. Okay, along with sorted as well. Okay, is that good? All right, and so I think that covers most of the list methods. You can always, as you go, you can type in Python list methods. And so if you're trying to do something and you say like, I feel like I should be able to do this in Python, you know, just go to Google and type in something like Python list methods, okay? And these will be the basically the list dot whatever, and this will list kind of the some of these things, and most of the hits on the first page of Google will be pretty good, okay? Generally, most of them will be pretty good, and then you can just kind of click any of these things, right? So we've got a lot of these things. We've got remove and insert and pop and all of these things, and I didn't do every single one, but I think I covered most of the important ones, and there's all sorts of other stuff, and you can kind of click any of these things to kind of see if that's what you're trying to achieve, okay? All right, there's something that is similar to a list called a tuple, okay? And a tuple looks a lot like a list, but the key difference is that tuples are immutable, okay? And what we mean by that is that, all of those lists that we've created were modifiable in place. You could change, the value of the object at index 3. You could pop a value and it changed the list. You could sort the list and it changed the elements or change the order of the elements in the list. Tuples do not let you do any of that stuff. Once you've defined a tuple, it is defined. The order of the objects are set in stone. The values in the tuple are set in stone. Okay. And so you create a tuple using parentheses, or you might call them curved brackets. I don't know what we should call these things, parentheses, right? And they are also created by default if you just write values without with commas, without any kind of bracket. Okay, so you can also do that in Python, and it'll just say, all right, I guess you're making a tuple here. Okay, so here I've created this thing called tuple, and I'm going to call it T, all right? And the indexing and the slicing, that works just like it does for lists, okay? So we can say what's the object at index 1, and it says apple, slice it from 2 to 5, so we're going from the second comma to the fifth comma, and it gives you back 2, cat and dog. You can say what is the index of dog, and it says it's at index 4. How many times does 5 appear? You'd ask for count, and that works. So all of these things that worked for lists also work for tuples, okay? But anything that was a method that modified the list, those things will fail, okay? So those things will all break, right? So here I've got two things that look almost exactly the same, except one is defined using the parentheses, so that's going to be a tuple. The other is using square brackets, that's going to be a list, okay? So I called the tuple T and the list L, okay? And then so with the list, I can say change the value at index 0 to 100, and it says, okay, I've done that, all right? With the tuple, if I say change the value at index 0 to 100, it's going to say you cannot do that, right? Tuple object does not support item assignment, okay? So the tuples don't let you do stuff like that, okay? Someone's looking for their phone. And then, okay, you cannot do append, right? So append is a method for the list where it just kind of tacks on this value here, okay? With the tuple, if you try to append something, it says the tuple has no attribute append, okay? Whereas with the list, you can append X and it just tacks on X to the end of the list, okay? So any of those, any of the things that modified the list are not allowed. So tuple will not have a sort method because that sorts the list in place and modifies it, okay? Here, I have 1, 2, 3, 4. I don't even have parentheses at all, okay? And if I say print out A, we can see that it's a tuple, right? Because it's got the parentheses there. So it shows up with parentheses, and we can say, oh, this is a tuple. And if you ask, what is the type of A, and it's going to say it's class tuple as well. Okay. You have a question?
Why would you want a tuple?
Why would you want a tuple versus like a list?
Yeah.
Yeah, sometimes you don't want the thing to be able to change.
So don't change it.
You know, this will disallow it. Okay, so like for example, if you ask like the dimensions of a matrix or something, it's going to return as a tuple and things like that and stuff. Okay, and you if you wanted to change the dimensions of the matrix, you have to deliberately change the dimensions of the matrix, and you can't just, like in R, say dim of the matrix is now 3, 2 rather than 2, 3 or something like that. Okay. So these are functions that support both lists and tuples as inputs, okay? So these are basically things that return information or copies of the object without modifying the object, right? So you can ask for the length of a list or tuple, and that's going to give you back a number, and it's not modifying the tuple or list, okay? You can ask for sum up the values if it supports summing, right? And you can say sorted works because it's going to return a sorted copy, and it doesn't modify the original object. So if you can sort a tuple using sorted because it is returning a sorted copy. So the original tuple remains unchanged, and you're also going to get back a copy of it that has been sorted. Okay, and then min and max, I think those are self-explanatory. So, so here I've got some digits, which will be a tuple of numbers, and I've got some words, which is a list of words, and the length gives me back 7. You can add some of these things. Obviously, some you can't do it for words, and it says, you know, I don't know how to do that, okay? You can sort the tuple, okay? When you sort the tuple, it doesn't affect the original tuple itself, okay? So the original tuple remains a tuple. Sorted actually returns a list, okay? So this is, it's gonna return a copy, basically a copy of the digits after it's been sorted, but now it looks like a list, okay? You can also sort, here we throw in the list of words, and it sorts it in alphabetical order, okay? Which is strange, but we've all accepted this arbitrary ordering of the alphabet. Okay, and then min for digits is self-explanatory, and again, and max for the words is also, it's going to be, you know, which word shows up last in the dictionary, okay, as far as max goes. So you can have min and max operations for words as well. Okay. All right, we've got strings and string methods, okay? So here I've got a string called name, and it is stats 131 Python and other technologies for data science, okay? Like a tuple, a string is immutable, all right? So you cannot modify a string in place, all right? So the original string in place remains what it is. You obviously you can reassign a new string to the object that has the value name, okay? You can just, if you wanted to change this, you can just write a new string and reassign and assign it to the object called name. But you cannot like modify the string in place, if that makes sense. Okay, so any of these things that we do, so if I say name.upper, this will create a new string, a copy, like a new string where everything has been made uppercase. Okay, capitalize will do the first character is capitalized. Title will do title case, where basically the first letter of each word is capitalized. It doesn't follow like English conventions where you don't capitalize conjunctions and prepositions, and I don't know what the rules are for capitalizing words in a title of a book. Is that what you capitalize nouns and verbs, but not, I don't know, something, right? It doesn't know that, okay? It just says, or it's going to capitalize the first letter of every word, okay? Lowercase turns everything lower, and then and here at the very end, it just shows that the original string name remains unmodified in all of these cases, right? So uppercase, capitalize, title case, lowercase, and the original string itself is unmodified there, okay? There's other, all of these things you can ask, how many times does the letter E show up? What is the index where the capital of the capital letter A, okay? And it just only gives us the first instance of it, okay? And these will be true, false answers. Does it end with K or does it end with E? And it's going to be true or false. Does it start with the letter S? And that's case sensitive, okay? So this, these are all just kind of, questions that you can ask about the string. And again, all of these things that seem to modify the string don't actually modify the string. They're just kind of creating new strings with these things. Okay. You can have multiple lines in a string. Okay. So here, so if you want to define a string over multiple lines, you use a triple quote to open and end strings that exist over multiple lines. Okay, and if we print that out, it indeed includes the multiple lines there. You can do split, and that will, strip, and that removes all the extra white space. And you can split, and it will split based on white space characters as well, okay? And split also kind of ignores adjacent white space characters. So here, so this returns a list with the string miles and the string Chen there, okay? All right, so here I've got a string with numbers and commas in there, okay? So here, if I do split, it defaults to splitting on space and it's not gonna do anything, okay? Whereas, it's gonna throw it into a list, okay, where everything is in one object. You can also give it the split character and say split using the comma, okay? And it's going to turn everything into a list and split it accordingly, okay? And whenever you do a string and you call split, the result will be a list of string objects, okay? So here we've split this string at the commas, and so now we've got a list of 5 string values. The string 2, the string 3, the string 4. Okay, these are not numeric values at this point. Okay. If you want to convert these two, say, integers, okay, you can take a string and you can throw it into the function int. Okay, the function int will do its best to convert some other object type into an int. Okay, and so. So int of x normally accepts only one value here. And so if you want to do it for an entire list, okay, so numeric string.split, this thing creates this list here, okay? And I think, in one of your upcoming homework assignments on Data Camp, you'll create a list comprehension. And we'll talk about list comprehensions soon enough. But here, basically, it just says, take each x, and for each x in this list, okay, so for each object in this list, turn it into an int, okay? Turn it into an int, and then take that result and throw that into a list, all right? And so here we get the list where everything has been converted into integers. All right. This is this list comprehension is equivalent to doing this. Okay, where I'm creating a for loop. Okay, for I say for x in this list that is created by doing numString.split. Okay, we can just we start off with an empty list L, and I'm just going to append the integer value of x. Okay, convert x to an integer type and append it to the list. All right, so we can grow the list that way. Yeah.
With methods like the split method, will it only take a character string itself, or could you use regex
as a way to split things?
If you wanted to split on all.
Let's see. All right, so let's do Python string split. Let's see. All right, we'll just go to this first one, and we'll also do the official docs. Okay, docs.python string. Let's look up split string. We want dot split. Okay, s separator. What can we throw in for the separators? If the second is absent, words are present is here. All right, let's. I don't know. All right, let's look it up. String split. Let's do regex. I feel like string split based on a regular expression. Can it be done by using? Let's see. This does not answer my question. This is just saying we can do some kind of white space character. All right, I'm gonna have to look this up, but maybe not string split. It looks like you could use a look ahead. All right. I'm sure we can find somebody who's done something. It might not have used string split though. So sorry, I don't know the answer right now. Okay. All right, and then we've got some true-false questions. You can ask things like, is it alpha? Okay, meaning does it only contain has spaces and digits? So is alpha will sorry, what did I do? Print name. Okay, so so is alpha is just going to say if it's only the alphabet characters, right? So the original name here has a space in it, and it also has digits in it. Okay, so it's going to return false. Whereas here, if I've defined a string with A, B, A, Z, okay, and I say, is that just alphabet characters? And that says true, okay? As soon as I throw in the number 4, okay, then it returns false, okay? So is alpha is just going to check if it's only an alphabet, and then I think there's a bunch of other things where you can kind of check, is it like alphanumeric and alpha, stuff like that. So here we've got multiple lines from the song Hallelujah, and you can turn everything into uppercase, and it looks like you're shouting. And if you can just split based on the spaces and new line characters, and that will kind of return based on the now you get a big list of all of these things. Okay. It might be useful to turn everything into uppercase and then split it, because now you don't have to worry about capitalization changing the words. You can also split lines based on the lines, the new line characters, and so so this creates a list, but now with four objects in it, because the original thing had 4 lines, okay? And then a bunch of other stuff like count and find, all of these things work as well, okay? So the difference between find and index is that if you ask index for something that doesn't exist, it returns an error. And if you ask find on something that doesn't exist in the string, it returns a -1 if it didn't find it. Okay, so that's the difference between find and index. So index assumes that the thing exists and will error out if it doesn't. Yeah.
You said that checking it all to like caps lock,
Uh-huh.
and then separating that with
Yeah.
a pair of punctuation issues.
No, not punctuation, capitalization issues. Yeah.
Oh. Okay.
Okay. You can actually treat strings as an iterable, okay? So here I've got the alphabet, and you can subset it and just say I want the first 0 index letter, okay, in the string, and it's going to give you A. You can say give me 4 through 9, okay? And there's no commas, but basically it's going to start, you can pretend that there is, okay? So it's going to start at, where is it going to start and where will it end? Okay, so it's going to start at the E, okay, and it will go 5, 6, 7, 8, 9. I think it goes E through I, if I'm able to count correctly, okay? 4:9, and then -6, where does that go? Okay, so we're going to count backwards. 1, 2, 3, 4, 5, 6, and that will give me the last 6 letters, U through Z, if I do -6:, okay, for all of these things. Okay, you can just like as if it were a list or an iterable, okay. I can take this string and I can say for 0 through 5. So this is going to do for the first 5 letters in the alphabet. For A through E, we're going to print each letter plus an exclamation point. Okay, so here I'm throwing this into a loop, and you know, now we're really excited about the letters A, B. I don't know. So there you go. Okay. I guess this is like your elementary school classroom, kindergarten classroom, and you're saying, give me the letters of the alphabet. Okay. Strings are immutable, so I cannot, okay, so in this case, S0 is currently the letter A, and you can't modify and say, I want to change the letter in the first position to be B. Okay, so this gives you an error, right? So it says string object does not support item assignment, okay? Here is like, if you wanted to change the first letter in the string to be B, okay, what you could do is you can just take the string B and then add on everything after the first letter, okay? So this would do it, okay? But this is the creation of a new string. You cannot modify values in the string in place. Do we feel okay? I know this is a lot of stuff here, but so we've covered lists, we've covered tuples, we've covered stuff with strings, okay? You can do some math operators with lists and tuples and strings, and we've already seen some of these things, okay? So here's I've created 2 lists, L1 and L2, okay? You can take a list and you can multiply it by 2, and basically it's doing it's kind of like doing addition multiple times, right? So you're going to do L1 plus L1. What's that going to do? When you do it with lists, it extends the list, right? So you're taking list 1 and you're adding list 1 to itself, and you've got now I've got ABC, ABC in a new list, okay? You can take list 1 and add list 2, okay? And it's basically appending them to each other, okay? A, B, C, D, E, F, right? these again create new objects that if you want to use them, you've got to store them. You've got to save them somewhere, which I haven't done yet. Okay. Here I've got tuples, and you can kind of do you can do the same thing with tuples. Okay. These are creating new objects, leaving the original objects unchanged. So tuples allow for this. Okay. You cannot add a list in a tuple directly. Okay, adding a list into tuple directly says that's not allowed. Okay, but you can easily convert a tuple into a list. You just say list, and you throw in the tuple, and it just basically just changes the parentheses into square brackets. Okay, it doesn't do anything really other than that. I mean, in memory it does something different, but it's basically just turning the tuple into a list, and then you can add it. So that's no problem. Okay. Similarly, you can do this with strings. String 1, string 2 is A, B, C, D, E, F. If you take a string and you do multiplication, it does this, and you can do this with this as well. All right.
Are there element-wise list operations?
Element-wise list operations? No. Not that I know of. There are not. When we'll look at NumPy, and NumPy allows does a ton of element-wise operations. But NumPy creates what we call arrays, and arrays are like Python R vectors where everything has to be of the same type. Okay. So with a list, you can have mixed type things, strings and numbers, and you cannot just take two lists and do element-wise things. I mean, I guess you can do like a list comprehension where you're saying like for each element in this list and each element in this list, combine them element-wise and then throw them into a new list. But there's not a native element-wise operator there. Okay. So one thing about this is this section, I hope you see the similarities between the behaviors of lists, tuples, and strings. Okay, we often don't think of strings as lists or iterables, okay, but or even tuples, but you can see that the behavior of a string is very similar to kind of the behaviors of the tuples, okay, in that, you know, when we multiply them or add them together, the tuples behave in a similar way and as the strings as well, okay. And you can kind of iterate over each character in the string as well. Okay. Booleans are your true false values, okay? So true, again, capital T, lowercase RUE, okay? You can convert them into ints and floats and strings and things like that. So you've got int, float, string, okay? So trues get changed to 1, 1.0, and true, the string true, okay? And then false gets changed to 0, 0.0, and the string false, okay? So no surprises there, I don't think. And the nice thing about Python is you know exactly if you're dealing with a float or an int because it's going to have that decimal place as well, okay? You can turn things into bools, okay? Booleans by using the bool function, okay? So by default, bool called on something empty will return false, and bool called on the none object, which is basically our null object, also returns false, okay? 0 is the only thing that will become false. Anything other than 0 will become true, okay? So bool on 0 becomes false, bool on 3 becomes true, bool on 0.0 becomes false, -1 becomes true, okay? The not a number type is nan, okay? We call this nan. And Python does not have an inherent missing value. There's no NA, okay? Python only has nan, and they use nan for pretty much all missing values, okay? And so we'll see that. So if you have integers and you need nans and stuff, that's not an option. You've got to kind of convert the integers into floats and then throw the nan in there, because nan is inherently a floating point value, right? Okay, and if you throw a nan into the function bool, it's going to become true, okay? So only zeros and empties and none type become false for the bool, okay? Empty strings become false, okay? So here I've got quote, quote, okay? There's absolutely nothing in the string, that's false. If you throw in space, okay? Bool on space, this becomes true, okay? And this is probably the trippiest one, is that if you take the string that says false, but you throw it into bool, it's going to become true, because only empty strings get coerced into false. So this is, we're not accustomed to this behavior in R, right? In R, you can kind of do a logical on something, but that's what we get, okay? So this feels a little uncomfortable, and these are just kind of the rules you have to kind of remember and memorize when you're dealing with these kinds of conversion things, okay? I mean, if you just remember that only empty things and zeros become false when you throw it into bool, then it's actually, it's easier, right? This is, the R's behavior regarding this is actually more like a special case. Okay, empty lists and empty tuples will return false. Everything else returns true. Okay, so here I've got an empty list. That will become false, okay? Here is a list that contains false, okay? It's not an empty list, so it's going to turn into true. All right, I'm not too sure when you're gonna try to call bool on a list, okay, to be honest, but you can throw like a lot of objects into bool and have it kind of coerce or return back a true or false thing, okay? Here is a list that contains an empty list, okay? So the original list here is not, it itself is not empty because it contains an object, which is an empty list, okay? These are all like the weird cases that like I'm throwing in here, right? So if we call bool on this, it returns true because it's not an empty list, right? Okay. If we look back at this list itself, L2 itself is false, okay? And of course, if you call bool on the false, it's going to be false, okay? This is actually stupid to do. Okay, I guess we ran out of time. Okay, so I will just cut this dictionary stuff and I'll put it into the next notebook, which we'll take a look at on Friday here, okay? You can expect your first homework notebook to appear online at some point, and you can start playing around with that as well. All right, we'll see you guys on Friday.